Let's get started. Welcome back. 21M 383, Computational Music Theory and Analysis. Went through probably one of the most slide-heavy, one of the fastest classes ever on Wednesday that I'll be doing this semester. Today, we're going to switch gears. We're going to do one of the least tech-heavy classes in this semester, and then we'll probably keep going back and forth. This is the only one that in my particular notes, for my lecture, it says, Mike, don't panic. There actually is no PowerPoint. Because I was panicking the other day when I was preparing this. I was like, wait, did I delete it? No, there is nothing. Because I want us to step back for a little bit and think about some of the things and do some work on some of the things to do with what we mean by music, because various musical points. Because there's a lot of things that we can know that are just sort of sort of intuitively, we all know what that is, but then we might not, we might not be able to explain it to a computer, because computers are smart or computers are dumb. What do you think? Shout it out. Dumb. No, neither dumb, neither no smart. Okay, I think computers are really, really dumb until we make them smart. So, or something like that. Great. There's some people in the back whose names I don't know. Could you take a sheet of paper? You can also use your outline to put your name on it, because the outline's for reading later. And it's kind of nice that this way you have it for later, and this way you won't sort of get me if I go out of order, right? Okay. So I'm seeing who your names are. Can you take a second and at least the person you're sharing a table or sharing the invisible table with and introduce yourself if you don't know that? Okay, now add into your conversation what you think a note is. You can also keep getting to know each other at the same time, but what you think a note is. Okay, I'm going to be asking you for some definitions in a second. But before we get to that, all I want you to do is take your definitions. You've kind of got them, first thing. And you just got to count notes, OK? So I'm going to sing some things, and you tell me how many notes I sing. So write them down, and then I'll ask them later. First set. Da, da, da. Pretty easy, right? Second one, da. Third one, do. Fourth one, dee da, dee da, dee da. And fifth one. Great. Talk with your neighbor and see how many, if you got answers that line up with each other. Okay, let's come back together. Let's come back together. We have I believe that the normal distribution of names in this class is kind of like the letters in the alphabet. So we'll start with J's. I'll call on. Who's the alphabetically first J? Is it Jason? Jason. Something like, and if I change the things, I'm doing it accidentally because I don't remember what I sang. But the first one, da, da, da. 3 notes. How many agree? How many disagree? Agrees. Disagrees? Good, that was the right answer. I sang 3 notes. Good, who's alphabetically next after Jason? We have some Jonathans, Jordans, we have Jake. Oh, okay, we went out of order. Sorry about that, Jake. No, even if we do Jacob or something, I'm still wrong. Okay, Jake. This is what I sang. Da. 1 note. Agree or disagree? Who agrees? Who disagrees? Good, everybody was wrong. I sang 4. Okay, next note. Well, next one I did, I went up, right? Next up alphabetically would be Jonathan comes before John and comes before Jordan. So Jonathan.
Okay. My percent was 2 notes.
2 notes. Good. Who agrees? Okay, we got some agrees. Who disagrees? Okay, good. We'll continue with the J's on that. John, you disagreed. What's the number that you came up with?
I thought because he's saying a lot, I would think he's saying at least 1 note.
Oh, no, okay. Well, greater than 1 note. No, greater than or equal to 1 note, right? Okay, so that takes a little. That's a pretty broad spectrum. I like that. It's always good. Who agrees with greater than or equal to 1 note, or wants more? Disagree if you want more specificity than that. Who agrees with greater than or equal to 1 note? Good. Jordan's on your side, and you just got some people. Good. So who disagrees with that? With everything beforehand up till now? Great. So I think we have no, Jason. We've already gone through. Who? Raise your hands again if you disagree. I want to keep going alphabetically next among the disagreeers, and that might be Karima. Karima?
Yeah.
Yep.
I wrote NA.
NA. Okay, we'll NA, or we'll make it so it parses in Python, not a number. Is that okay? Okay, good. And anybody still have your number not said? Adam?
Yeah, I said 14 or 15.
14 or 15. Okay, very specific. What did you base that on?
So you went from a C to either C sharp or a D. So it's like if you go through all of the chromatic notes and slur them all, that's what you get.
Okay, good. So we have a range extension. Good. Anybody else have a number that hasn't been done yet? Okay. So that's particularly good. This one I went with inf. Oh, sorry, I wasn't telling you what my numbers were yet. Okay, well that's one I went with. And then next one, dee da dee da dee da. We have some other. Do you want to? We have a listener, but do you want to be a participanter also? Yeah, go ahead. So with that one,
I wrote 6.
6. Anybody agree? Yep. Anybody disagree? Good. Okay. And yep. And now, no, I was giving the right numbers. Yep. So I'm going to say I did that. Nobody disagreed. The correct answer there was 2. And don't worry. This is much frustrating. Be frustrating. And then, who's also around K, or do I hear L? 0. Anybody disagree? Great. A person who's disagreed who has to speak.
I just said 1.
1. Good. Who agrees with 1? Good. How many people have heard neither 0 nor 1? Yep.
So when I was writing a lot of these, I put 2 answers for a lot of them, depending on how.
Yeah. Okay, but you can only give 1 right now.
Yeah, well, it's depending on how I notate it, how I'd like pitch wise, and I was taking
Oh.
I was taking perception, talking about spectrograms, and a clap has like all of the.
So give me a number.
So that one would also be inf.
Inf. Okay.
But
good. This one I'm going to go with 0. And I will tell you, there isn't a single answer on here that you couldn't argue for and be correct. So why? 3 notes, I think we all agreed, because I think I sang bum, 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 and I count each of those as 1 note, right? Second one was 4, because da was a whole note tied to a quarter note, tied to a 16th note, tied to a 64th note. And I do believe that is the closest, shortest representation I can do notationally. So I was thinking in a notational sphere here. This time, with the glissando, I was thinking of it as an infinite number of notes, because if it's continuous, it could be. But on the other hand, any of these other ones could be correct. Now let's see if anyone can come up with how from dee da dee da dee da I came up with 2. They're 2 different pitches. That's one good way to do it. I'm glad I hit the same pitch each time, maybe, because I'm close. That's not the reason why I was thinking. Yeah?
It's like the tremolo.
Tremolo, yeah. It was something like, I don't know. Well, don't know what thing we're in, but yeah, I was thinking it as something like that. Or actually, it would be measured tremolo, wouldn't it be? Like, anyone know this sign where you have a beamed, or no, just one beam, right? 2 beamed dotted half notes. You see it everywhere every once in a while when you're playing like Prokofiev or Schubert and stuff. And I always like, oh, I have to remember what that is. But that means fill in the space of 1 dotted half note with as many eighth notes as it takes to fill it in, alternating between the top one and the bottom one. And clap, I thought a note to me had to have some sort of specifiable pitch. So I count 0. Now, everything that somebody said, 1 for this, or infinite, are all valid definitions of what we're going to be talking about. And here's the thing. 99% of the time, when I'm not trying to set up an example for, for kind of having fun in the first week of class with you all, there's no way I would call that second one 4 notes, right? I mean, if I hear it, I'm going to be 1. So one of the things that's going to come up quite often is that depending on what purpose you want to do with something, you're not going to be able to necessarily even know how many notes or how many of something there is, let alone what's the correct spelling of something or not. So I think we're just going to be playing around with something like this. Now, go back to your definitions of notes that you had before, and let's grab into groups of 4. So your 2 groups that are the same, joining with the group behind you. So that's we're going to get good at spinning over here. We'll create a group of 3 here and 3 here, and we'll break up this group and talk about what your definitions of the notes were with the other group, and then try to figure out, A, if you had correct definitions, or if you had compatible, it's not a correct definition, compatible definitions of notes before that with each other's group, and then also if you want to change definition based on all the weird numbers that we came up with here. So go ahead and let's take a couple minutes to do that. Great, let's all come back together and there was one word that I just kept hearing as I was going around, and it begins like this. When any group use a word that begins with this in their definition? Yeah, John, go ahead. Representation, yeah. Representation. So we can kind of start with a note is of. Is anybody's definition completely incompatible with this opening? Like, couldn't be put in? No, smile thing. Okay, so what are some of the ways that your groups could have done this? I didn't think I heard, because it's physically difficult, what Jonathan, Karima, Jordan, and Misha's group came up with. How would somebody in this group continue that? Everybody has, you guys are all normally distributed names, so I've heard from everybody. So Karima, would you like to?
I think we said anything with pitch and duration.
Is a representation of anything with pitch and duration. Any groups disagree with that? Yeah.
So I'm coming at this from the percussion perspective.
Uh-huh.
where a note doesn't necessarily need a pitch and it doesn't necessarily need a duration.
Okay, so we have not necessarily on that. So do you have a positive? Did your group come up with a positive definition from that?
I don't think our group came into agreement.
Good. Let's hear some.
View is a note as a representation of an instance of striking something.
An instance of striking something. Okay. Anybody? So it's Matthew. Anybody want to go forward with that? Like, sorry, I can't talk and write something else at the same time. Anybody's that's perfect for out things while you're speaking? Anything with a pitch and a duration. I think an airplane on an airline flight has its pitch and duration, right? So I'll start calling them notes too. No, I'm just having fun. Just trying to get us to think so we can start making things how we're going to make this happen for a computer. I like both of these. An instance of striking something. So yeah.
I feel like that doesn't really apply to certain instruments, like violins, for example. You don't have to strike anything to issue the next note.
Good. So, it's somebody who hasn't spoken want to defend an instance of striking something as applying to the violin. Yeah, go ahead, Vanessa.
So I mean, if you want to be annoying, you can use like a version of striking in a much more general sense. It doesn't necessarily have to be like hitting anything. It'd just be when you're moving a bow across strings. You can say that that counts as like a form of striking, even if it's not like the most straightforward definition.
Okay.
What about a wind instrument?
What about a
Like
wind
slide
instrument?
whistle?
Okay. Who's y'all? Most of you are juniors and seniors and things. So most of y'all have gotten through your physics mechanics general institute requirement. Anybody want to say how's sound produced or perceived? Maybe moving
Vibrations of air.
vibrations of air. Good. And so there's a lot of air vibrating way down the street. Why do I not hear it? The inverse square law. Yes, that might be, but what is not happening with the movement of air?
It's not reaching our ears.
It's not reaching our ears. It's not. What is one of the first thing it reaches in our ears?
Eardrum.
Eardrum. Oh. So maybe there is a way. So we could say an instance of something striking something, such as air striking a drum. Before half an hour ago, how many of you would have said that that's a note? Okay. What's it striking?
It doesn't need to strike. You said it's a representation of something.
Oh, it's a representation of something striking. Good. Okay. Any other things that we want to do with confusing definitions before we get to one of the points of this class? Okay. Any other really great, beautiful things that wasn't covered here? By the way, I forgot to do this part on there. How many notes?
3.
Okay, so if there's something about when you play that, the 3 different sounds being done could be considered 3 different notes. So is a chord a note? Or is a chord a bunch of notes? Or is a chord something else? I'd say this because we're going to spend a lot of the first problem set in the next week is going to be on how to represent music for the computers. As of the 1960s, for a computer. So what kinds of choices will lead us into bad places fastest and which ones will keep us in good and useful places for the longest amount of time. Notice I didn't say which ones will never lead you astray, because you're always, every definition that you're going to encode into a computer at some point is going to completely screw up something. For instance, we might say one note, add a little ornament to it. Still one note in some certain senses, but ya-dee-da-da-dee, that kind of turn can really change everything. So those are going to be coming up over and over and over again. How to represent for a computer and whether or not any one representation is going to work. Somebody said a note is a representation of anything with a pitch and a duration. There are some people who use the term note and the term pitch absolutely interchangeably. And I do it sometimes also. You know, what pitch was that? What note did you play? Things. And other people use a note to mean the pitch and the duration as two different entities. Now, obviously, that also leads to certain contradictions. I would hope that we think that an eighth note is a note, right? I mean, it has the word note in its name. We're not talking about quavers in Britain. I mean, at least here in good old US of A, we put the word note in our eighth notes. But by this definition, pitch and duration and eighth note itself is not a note, because it doesn't have a pitch. So we're going to be finding that we're going to go back and forth quite often. Now let's, your problem set is going to be dealing with certain representations of pitch, at least the non-duration part of something. I will say, I sometimes will pop ahead when the lecture is getting too cerebral and things like that. In Music 21, the software we're going to be using quite often, this is probably the best, closest definition to how Music 21 associates things. It's something with a conceived of single pitch and a conceived of single duration. And that might mean that something like this is conceived of as having a single pitch, or this is conceived of as having a single pitch. That's a trill sign. But there are other times when we don't conceive of something as a single pitch and duration. So let's talk about representations of duration. So we've gone from the trick questions, and now, now I hope I haven't ended your faith in humanity in the class. Now I want to go to some a little bit more thinking about standard situations, and not weird tremolos and glissandos and all that stuff. I want to think about how are some ways you might represent pitch, duration for a computer. And we'll say, I'm going to put the term here, musical, as if somehow there's a different world of time in music than there is in everywhere else. It's sort of, there's three kinds of time in the world. There's the one on your clock, there's the one on music, and there's the one they teach you about in relativity class that you hope you never hear again, right? So thinking about this, what are some ways that you might do it? I think we've grouped enough. I think people want to be able to shout, and some people whose names are toward the beginning and end of the alphabet might want to be able to say. So what are some of the things that a musical duration representation might include? Okay, I think that's good enough. I think it's sort of like doing jumping jacks. You just sort of get the thinking calisthenics going. So what's some of the things that you might do for representing duration? Jordan said something. Yeah.
Like seconds, like a unit measure.
Seconds, good. Now let's think about it. We'll make our default assumption for this class that we're thinking in Python. Of course, obviously, any halfway decent programming language can go for another. So how are we going to represent seconds for a note? Yeah, go ahead. Oh, was that?
I guess typically we use ticks and kind of frames.
Well, we'll get to that. Keep that word there for a second. Great. But what kind of is string a good one? Array. How are we going to represent seconds? Yeah, go ahead.
Like a float.
Float. Okay, good. Why not int? Yeah, just shout out. Yep, go ahead.
Because we can have in between, like.
Good. Good, we can have in between. Great. Super. Other things. I'm going to, other things you might want, ways you might want to represent duration. Yeah, go ahead, Matthew.
Fraction.
Fraction. Good. And is that fractions, seconds as a fraction, or?
So I'm thinking both represent seconds as a fraction instead of a float, so you don't have the precision issues of a float. I also think it might make sense to represent it as a beat. And
Okay. We go. That's two many things. We have beat there. Good. We'll keep going. What are some other things that we might do? Yeah.
I was also thinking fraction, but like fraction of whatever measure you're looking at.
Fraction of measure.
So if you had like a 3/4 measure and you had a half note, that would be 2/3 of the measure.
Yep. Okay, so good, 2/3. That's a particular place where the difference between float accuracy and fraction can be very, very important. Good. Are beat and fraction of measure basically saying the same thing with a reciprocal relationship? Can somebody come up with a reason not to? Yeah, Vanessa.
I mean, not necessarily, because like something could be on the second beat and have like a duration of 1, or it could be a second beat and have a duration of 2. And if it was a fraction of a measure, their values would be the same.
Okay, good. So we have beat as in what beat is it on, and that would be very different. If we're thinking about how many beats does it last, though, because thank you, Vanessa, this is fantastic. Is that basically the same as what fraction of the measure is it? Thank you. I see Matthew, but I want to get. I think I've been going this way because I'm camera shy. So let me lean in over here, see if there's things. Anyone want to? Who says it's basically the same thing? And we can go all the whole room. Who says it's could be quite different? Okay, go ahead.
I guess if it was like, depends on what you define the beat as. So if it's like 5/8 time or something.
Oh, okay. So 5/8, we'll do it as this. I don't know if people know that symbol. So how many beats does this get? 2 in some ways. And how many this one? 3. Good. And now give me another number so we could use instead of that for a lot of 5/8. Yeah.
10/16.
10/16. Yeah, we could do any other. Good. We have an infinite number of non-reduced fractions we can do. Great. I love it. How about this? No, I won't write that yet. How many beats does this get?
Undefined.
3. 3 is a good answer, and there's another good answer. 1. Bum, 1, ba 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 1, 2, right? So how many beats does this get? So there's some ways of doing it. When I put this symbol, I'm saying I'm going to go 1, 1, 2, 1, 2, and they're not. So a beat can actually change its length during a measure in some representation. So this is one of the ways I was thinking, not exactly the same thing, but pretty close. Good. Let's see. What are some other ways we might represent duration for a computer? I'm going to go back to in just a little bit the names, some of the things I've heard other ways. I heard something over here that I think Adam or say one of you, Derek.
Like an attribute, like a dot is like an attribute.
Great. So we might keep track of attributes like how many dots does it have? Good. Anything else like that? Thank you. Super. Yeah.
Yeah, you take a number for the nth node it is. So if it's an 8th node, you say 8.
Okay.
The dots would be an 8 dot.
8. Okay, so we can represent it as now. 8 dot works pretty well as a float, but is there another way we might consider that if we're talking?
It works well as a string.
It works better as a string, right? Because 8 dot dot, suddenly you're kind of getting a crash error, right? So that's one way you can do it. Other ways, and then so we would say 16 dot or something like that. Good, good. What are other attributes we might want to represent to talk about the duration of a note? Are all notes, yeah.
You could also have things in a triplet.
You could have things in a triplet. Yeah. Good. You could also have things in a quintuplet, right? Let's see if I can squeeze this in. And you could also have things in a triplet within a quintuplet. This is called nested tuplets. I will guarantee you I have seen at least 20 representations of notated durations where the tuplet was originally created as an attribute, and then it needed to be represented as a list array, tuple, something like that, of a tuple of tuplets. Try to say that 10 times fast, for an indeterminate number of tuplets that might be applied to a certain note. So these might be certain things. Good. Anything else that we might use to represent duration? Yeah, go ahead.
Certain markings like staccato or like a fermata.
Good. So we might have modifying, I don't know, articulations and expressions or markings. We'll just call them markings because who knows what they are. Markings. I'll make a fermata on my eye. Good. So yeah, we have our dots, maybe modifying. Good. So we can think of tenutos, that those affect the duration. Great. Now, I don't want to go too much further on this. Now our music is on, I was going to use obsolete formats, a CD or streaming. What are the most useful representations of duration? Of notes, let's say, or other things. Which ones of these are most useful? Yeah, I've heard you a couple of times from you, so great, super. Am's got it. Who else got one? Is this a great duration that you representation that you're hearing of the duration of a note when you're listening to streaming music? Maybe not, but boy, that could be useful for other things. What about seconds? That's going to depend on, let's say you're listening just for fun. Seconds very good? No, maybe not. I don't usually hear seconds, but who's somebody involved in the streaming music process who might really care about seconds of notes?
I guess like computers.
The computers, right? Yep. But what kind of human might be really interested? Yeah.
Some editor person.
The editor, yeah. The person who's doing the recording editing. They're always going to be thinking about, okay, let's clip from 22.046 to 22.048 when somebody coughed, and we'll come up with something, right? So those types of things come up quite a bit in that type of world. Now, what if you've written your great piece, it's already been recorded, performed, and things, and now you've sent it off to your sheet music publisher. What are the ones they're going to care the most about? What's the representation? Yeah, John.
Pitch and duration.
The pitch and the duration, good. And how are they going to be thinking about duration? How's the engraver, that's the person who makes musical scores, the term for that. What's the engraver, what's she going to be thinking about in terms of duration? What do you think about when you're looking at musical scores? Yeah, Misha?
The beat and then the modifying.
The beats, the modifiers, good. what are we going to call something, the difference between an eighth note, a quarter note, half note, all that stuff? What do we want to call that? We all have been doing music for a very long time. We all must know the term for that, right? There is no generalized term for it. So what do we want to call it in this class? Somebody shout out something, or we'll call it the note animal. What animal is this note? Or what flavor is this note? That's a good one. Actually, I wish I had gone with that. 16th notes are really, really tasty today. Anybody have a suggestion of a term?
Essence.
The essence. What essence of note is? Good, good. I will tell you that essence is better than animal, probably as a term. It's probably better than flavor, and it's better than what all the rest of us didn't say, because the first thing you have to do when you're representing for a computer is come up with a name for everything. Yeah, Vanessa?
Oh, no.
Okay, but come up with a name for it.
Duration.
The duration. Okay, so we might have the duration of a duration is a quarter, and the number of dots is 2. A lot of representations do that. I think MEI calls that part a duration. So that's a very good term for it. Other terms. Get good at naming things. Come up with names fast in this class. So let's just pepper some bad names for it. Jonathan, what's that?
Almond.
The almond. What almond is it? Jonathan.
I mean, I guess length.
What length? Good. What length is that note? It's a quarter note. What length is that note? It's an eighth note. There might be a better term, but that's a pretty good one. That's good. Yeah.
I feel like span isn't.
What span? I like that. What span? I mean, it might not be so perfect, but you know, it gets us when you think about things. What's something that spans things that people spend a lot of time, especially at what course 3, thinking about? Bridges, good. And when you start thinking about bridges, what's something that we haven't even thought of that looks like a bridge when we think about durations and notes?
Slur.
Slurs, ties, good. Slurs, ties. I was also thinking of beams, any of those, good. So when we start thinking of terms like this, we start thinking of cases. Who had thought about ties and slurs in your definition? Who had thought about beams? I hadn't thought of ties and slurs. So when we do these types of things, suddenly why something is a good name or might not be a good name can help us think about what other things we're going to have to represent. I'm looking at the time. We're not going to be able to get through all the different types of representations here. But good. Now, what would it take? Let's say you have this. What's it going to take? That's dotted quarter note. That's not a trick question. What's it going to take for you to figure out how many seconds that is? Who has performed music from sheet music in this class in their life? Okay, it's basically everybody. So when you do that, you have to decide how long you're going to play that, right? You might not even be thinking it in your head. I've never been like, okay, I'm going to play that for 0.365 seconds. How do we go from this to a number of seconds? Yeah, go ahead. Oh, sorry, there was 2 in a row. We'll go behind first.
Well, I mean, it's based off the tempo.
Based off the tempo, good. Has tempo been included? I suppose it's almost implicitly included in beat, but tempo is a particular term. So we have tempo. How do we measure tempos? Tempi. What's that? Beat per minute. Good. Beat per minute. So what do we need to know also in addition to tempo in order to figure out how many beats something is? We all think of 4/4, right? So yeah, Jake.
Did you intentionally say 0.365 because it's 3/8 of a second?
Yes, that's
375, but yeah, so whatever. I don't know. It was something like that. Yeah, I rarely do anything intentionally, so maybe it's karma. What do we need to do to get beats per minute? How many beats is this?
depends.
Depends. Good. Depends on the. Everybody shout it out. Time signature. Good. So suddenly, moving from this representation of notes to seconds, we need tempo in beats per minute and a time signature. Good. Let me give you another one. What if I said the tempo here was allegro ma non troppo? Okay, well, the other thing, if it gets too much longer than that, the other thing we need is an Italian dictionary, right? Allegro, but not too allegro, not too much. So what do we need also in order to convert this to seconds? Let's take a stab at it. You guys have all been speaking pretty well. Hannah, I don't think I've heard from you in a little bit. What would you say you need in order to convert this to?
I guess like knowledge of what
Knowledge of?
like what it means in terms of the tempo.
Knowledge of, good. Knowledge of a conversion. Can you give me a conversion, maybe what it means, conversion to, let's say, BPM? What would be, what's somebody, Hannah, if you want to, or pass it along to somebody else, take a stab. What are you going to name that? Allegro, approximately? $7? Okay. 2 million. Okay, good. We're narrowing it down.
Maybe around like 110.
110, good. Anybody want to go higher than 110? What do you want to go to?
126.
126. Very specific number. Anyone want to go lower? I'm going to go a little bit lower and say 90. Because the other thing that you need to know is the cultural context, and because each of these things changes so much. Handel has a tempo marking of allegro adagio.
Oh.
What does that mean? Those are like contradictions. That's like, you know, how do you like your cereal? I like it hot cold. Yeah, but at a particular time. So sometimes we ignore quite a lot of these, right? I know I use, and by the way, Hannah, pretty close, I think I use 118 in a lookup table when I have no idea what I want to do from Allegro. Or sometimes I've used 126, I've used other things, 110s. 110 I usually use as it depends on whether or not I have a conception of the term allegretto, in which case I need to make room for that. But yeah, 110 is also very good. Good. By the way, every guess that people are doing has been really, really, really good in this class. So just keep taking the guess, and when we start talking too much, then I'll slow it down. But it's good. So these are all the various things that we might do to convert from one to another. There was one other way that we could measure duration that I think Marlon said that I was like, shh, not yet, not yet, not yet, but it becomes very important. Do you remember what we said? Ticks, good. So you can measure on the number of bugs that get into your hair when you go hiking, right? No, what do we mean by ticks? This has a different meaning than.
From my understanding, it's how like the computers have process like whatever program or application you're running, and that measures in kind of like ticks, and so that kind of dictates what a second is based on it.
Great. Yeah. So what we can do is we can think of time as somehow discrete. That time moves forward. And by the way, there's some theoretical physicists who've been trying to study whether time actually is discrete and moves forward in, I don't know, 10 to the negative 58th seconds or not. But that we can think of musical time as a discrete number of something in a purely computer world like ticks, which is both brilliant and a way of just shuffling later to some other later part of the program, the actual conversion of this to seconds or to quarter notes or to eighth notes or anything like that. But it's very, very useful. The one term that you may have heard of before, MIDI, the MIDI file format, the MIDI things, MIDI tends to measure everything in ticks. There's some things are not, and it's a little bit of a simplification. So ticks end up being sort of ticks per second, or ticks per second is a pretty good one for tempo, and the other one, ticks per quarter note, comes up quite a lot. Intriguingly, because of the problem of 6/8 and 5/8 and these weird things, fundamental measurements in terms of beats have not primarily been taken on by people who do musical representation. It's generally seen as a slightly higher representation, which is ironic because it's one of our fundamental ones as musicians, right? I mean, you think of that, oh, that lasts half note, it lasts 2 beats, right? And then somebody reminds you, ooh, what about cut time? You're like, you ruin everything, right? You know, because we generally do some things like this. I will share now what I ended up in my program in Music 21, decided that for some reason the quarter note is the fundamental measure of everything else, so that everything tends to get measured in quarter lengths, which is a terrible term. Boy, I wish I had come up with something better. Essence, that's good. Almonds, I wish I had measured it in almond, because quarter length takes a very long time to type with the camel case in the middle. And we didn't have, GitHub autopilot and things like that. By the way, I did mean to put no ChatGPT on the syllabus. I put it on the thing later today. You have fun with it, but not when we're doing any sort of writing your essay or anything like that. But maybe we'll come up with a chat music or something later on this semester and try to see how we can do things like that. But yeah, I wish I had come up with a better thing, but almost everything measured in quarter lengths. What's nice about that is how many quarter lengths is a quarter note? One. Good. We're all still awake. I know it's Friday late and things, but yeah. So I don't. How many quarter lengths is a quarter note in 6/8? One. How many quarter lengths is a quarter note in Allegro? One. So these things, but then how many seconds is something that's 1.5 quarter lengths? Now you have to keep up with everything. So you can kind of think about, when you're thinking about, now let's get to the first word in this class. It's not representational music theory, it's computational. When you're starting to think about, I'll abbreviate it quite often as QL, to sec. And maybe we'll say secs or floats in this case. I use a lot of typed Python, by the way, where if you haven't ever seen this, you'll put this in to say what I expect to do. So it's sort of, all the joys of having to type more things without type safety. It's not so good. But what do we want to put in as our attribute or attributes here? We're going to return a float. What's the first thing that we need? QL to seconds. How many QLs? Yeah, so maybe it'll be QL. Some people like to do QL in, and that's going to be measured in, what do we want to make that? Float. Good, could be a float. Int's probably not good enough. Name something not representational as an int in quarter lengths. Eighth note, good. The issue, I tend to sometimes use the fraction class if you haven't ever done that, because the first time they had 3 triplets add up, actually triplets work fine, 5 quintuplets adds up to 1.0000146 quarter notes. That's when I started moving that, but float's pretty good. Good. So that's attribute 1. Is that, anybody want another attribute in there? Quarter length seconds, yes.
Like a tempo?
Tempo, good. So we can define a tempo object, and now we're going to see, or a struct, or some kind of a thing. Well, tempo could be a basic thing. It could be a float, right? What else could it be? What do we, if we're not thinking about allegro non troppo as used by Handel as opposed to Mendelssohn or something like that? What do we, yeah?
Beats per minute.
Beats per minute, okay. So we have beats per minute. That's the most common one, right? So that's going to be, how do you measure beats per minute? Oh, sorry, how do we want to represent it? Float, good. So we pass in first thing a quarter length, second thing a tempo. Is that enough? Why not?
Time signature.
Time signature. In order to define, what are we defining by the time signature?
How many beats a quarter length is?
Great, beats per quarter length. So TS, we'll measure in beats per quarter length. And what do we want to make that also? Float, good. Let's do this. You don't need any sort of, go ahead, grab laptops. Let's implement quarter length to second. Let's do it as paired programming so we learn from each other. So the person on the left is who's done paired programming. Person on the left is the driver, unless the person on the left doesn't have the thing, and that's your left, not my left. And everybody else will, that 4:34 will take about 10 minutes. Okay, just before we continue and start going on any things, how many people wrote 5 test cases before you started? How many people wrote 10 test cases? How many people wrote 1 test case? 1 test case. How many people wrote 0 test cases? Okay, this is, you're going to hear this a couple times in the next class and stuff. And this is very different, guys, just 1 second, and you get back into it. Very different from a lot of the, especially intro level CS classes at MIT. But because this isn't a really big established field, I told all y'all that you're really, this is one of the very few classes like this, right? One of the really important things is writing test cases, and especially looking at corner cases. So get in the habit of this. You're going to, if I'm feeling nice, I might give 1 or 2 test cases with correct answers on things. But a lot of it is sit down and think at 60 beats per minute, at 4/4, how long, what's the answer for a quarter note for 1? 1, good. At least make sure your code does that before we go on. So keep going, try some running and try some. Okay, let's all come back together for a bit because this isn't the problem set, and I want to kind of move on and things. One of the terms I heard a lot was this one. Let's do a dimensional analysis, or things like that. For somebody who didn't use that term or who doesn't, we're all coming from different backgrounds and things. What's a dimensional analysis?
Stoichiometry.
Stoichiometry. Well, thank you for obfuscating further. We'll get you on the cult. What's that called?
Stoichiometry?
Stoichiometry. I must have failed trigonometry, so I didn't get to that one. What is okay? What might that mean? Honestly, I just learned a new word. Thank you.
That's just dimensional analysis for chemistry.
That's just dimensional analysis for chemistry. Okay, good. Remember, I was up the river, so we didn't learn these things. What do we mean when we talk about dimensional analysis? Yeah.
It's like a conversion between equivalent units.
A conversion between equivalent units. Good. What are some of the dimensional analysis things you've done before this class? Things. Yeah.
Physics.
Physics. So what's a dimension? What's a kind of
convert we're trying to convert it's like meters per second to like miles per hour.
Great. Meters per second to miles per hour. Absolutely. Thank you. So we have the particular conversion there. So we have meters, seconds, miles, hours. What were some dimensionality things, dimensions that you use now that you might not have used in your past before? Yeah.
Beats, quarter lengths.
Beats per quarter length. Beats quarter length per beat. Good. Beats quarter lengths. Absolutely. You've probably heard beats per minute. Not everybody has thought of it as, okay, then I have to convert to beats per second, which is not something we think about. We're very, very good at thinking about beats per minute as musicians. We're very, very bad at thinking about beats per second or seconds per beat. And then beats per, what was the other thing? Beats per quarter length? Awesome. So that came up quite a bit on things going on. What were some other things that seemed to stump or be fun or interesting or that you learned from programming this? I heard a lot of, we don't need the time signature. I think I heard that aloud at least 3 or 4 times. So, but what do you do if you have the time signature? And the problem, and let's say we're leaving out that 5/8 where the beat changes stuff. How do we convert from time signature? Let's think of time signature first as a struct, as a 2 tuple of numerator and denominator. How do we convert a numerator and denominator into beats per quarter length? What is 4/4? How many beats per quarter length? Good. What is 2/2? How many beats? Oh, good. I did hear it, but I heard a lot of. I love it. This is what I'm hoping to get to his class. I heard a lot of very loud wrong answers, and then very, very trickling right at the end, a little whispered right answer. How many beats per quarter length for cut time for 2/2? 2. And I also heard whispered. Somebody had. 1/2. How many beats does it take to play a quarter note in 2/2? How long does each of these? Is that correct? Or am I wrong this time? Half a beat. This is half a beat and it gets a quarter note. This is half a beat and it gets a quarter note. Okay, what about in 3/2?
1/2.
1/2. So what part do we not need? Numerator. So for this particular thing, we don't need the numerator. We would if we, yeah, go ahead, Matthew.
Don't we need the numerator in 6/8?
Do we need the numerator in 6/8? Yes. So what do we need the numerator for? We only need the numerator to do a modulo operation to compare if it equals 0. But is that good enough? Because 6/8, 9/8, 12/8, these all generally default in most conceptions, not all, but in most conceptions as the number of beats is divided by 3 on that. So is that good enough? Does everyone know modulo notation, like the remainder when divided by 3 equals 0? So does that work? 6/8, great. 8/8, nope, that's a normal one. 9/8, great. So 6/4, great. That's 6. How many beats does 6/4 have? Treated in this way. 2. 1, 2. 1, dot, dot. 2, dot, dot. Yeah, I say it has 2, and I mean 1, 2, 3, 4. But I'm giving you the big one. Great. So 6/4. How many does 9/16 have? 3. Great. So this works, right? We have all our good test cases there. Yeah, you're smiling big. Anyone else smiling big? You're smiling big. What's the test case we've missed?
3/4.
3/4. So 3/4 has 1 beat, right? Because you divide by 3. So what do we have to do? If the numerator modulo 3 equals 0, and num not equals 3, right? That's assuming we've already done our assertion that numerator is positive and all the other things, right? So these are the algorithms that you already know in your head for music by being musicians. But they are not the algorithms that you have been programming before. Here's a particular one that I always like to do, and I don't think we're going to have time to go through it today because you guys have been such great participants in my terrible ploys and things. Given a note, given a quarter note, let's say, we'll keep it really simple because we're already in. We'll call the quarter note one quarter length, 1 beat or something. Given a dot, how many beats? 1.5. Given 2 dots?
1.7.
3 dots? Oh, somebody had it. We're going to trail off. Good. N dots. What is the formula? Oh, yeah. So working this out, and if you want, I'll put a link online. Once I originally had to write out this formula because I kind of needed it, it becomes kind of fun. So yeah, so it ends up being, what do you call them? These are Mersenne numbers, which are not the same as Mersenne primes. They end up being sort of n minus 1, what is it, 2 to the n minus 1 over 2 to the n. So you end up 1 and 1/2, slightly under 1 and 3/4, 1 and 7/8. So 2 to the n, whatever. So you can begin to figure out, okay, and hopefully that works. 2 to the 0, sorry, that goes down below. That's not part of the exponent. I should make that nicer. 2 to the n minus 1 over 2 to the n. Sorry, I haven't been writing on whiteboards in a year, so my technique's a little low. So does that work, or 1 plus, right? Yeah, so does that work for 0 dots? What's 2 to the 0th? What's 2 to the 0th?
1.
1 minus 1 is 0. So that cancels that out as long as that's not 0 there. Good. So you get 1. What happens if you have a negative 1 dot? Two to the negative 1? 1/2 minus 1? Negative 1/2 over 2 to the negative 1? Over 1/2, and what's that end up? Negative 1/2 over 1/2? 1 plus negative 1 equals 0. So every time you don't hear any music, no, you're hearing the grand symphony of negative 1 dots. I think that's a good place to wrap up.